Every year in the northern climates, we end up winterizing irrigation systems. Several years ago, Toro introduced what you see pictured here, the system winterization and pressurization procedures, a best practices and a guideline for people to follow when winterizing their system. It's recommended for all brands of irrigation systems, not just Toro. For a Toro system, Toro does require that this irrigation, winterization, and startup be followed. What we're going to do in this presentation is just highlight some of the important content from this document, as well as draw out some best practices and put it in an illustrated way that's easy to follow and understand. So first off, from a quick reference perspective, 2 days prior to blowing out with compressed air, we want to open the high point vents, the low point drains. We want to allow the system to drain as much as possible. We also want to identify the locations where water collections are likely to occur. Secondly, we want to attach the compressor at the highest point possible. Sometimes we cannot do that, but when we can, we like to do it at the highest point possible, and introduce air to the system to force the water out of the low point drains. And as we do that, we close the high point vents from the highest to the lowest in the system until no water is present coming out of the low point drains. Then we'll close the drains from the highest to the lowest points as well. When all that is closed down, we'll regulate the compressor air pressure to be 35 to 50 psi, and we'll activate as many sprinklers as possible based on the size of the compressor, while maintaining enough pressure so that we can activate the sprinklers. We'll turn on each sprinkler head once, forcing the water out through the nozzles until a light mist is coming out and no more water is coming out. As the heads are turned off, new heads will be turned on to maintain continuous flow and pressure. And then number 5, in locations identified in the first step, when we were just draining, we'll either remove the riser assembly or we can insert a riser hold-up tool, which is part number 995-102, and activate the sprinkler again to remove any residual water, and we'll repeat this as required. We'll use that tool to keep the riser in the upright position so it's not slamming up and off when pockets of water come through the pipe. And number 6, then, we'll close off the winterization tap, store everything, and prepare for winter. So some warnings before we begin. This is of utmost importance. It's why it's in all caps. In the brochure, it's in all caps. To prevent personal injury, never attempt to disassemble the system while under pressure. And to prevent personal injury, don't stand directly over any sprinkler when activating manually at the sprinkler. Cautions. Don't exceed 50 psi of air pressure in any system. Exceeding the 50 psi can result in severe equipment damage and personal injury. Activate each sprinkler only once. Subsequent activations with no water in the sprinkler can result in high-speed activation of the drive assembly, which can cause damage and melt things, excessive pressure spikes, possibly resulting in equipment damage and personal injury. And then the pressure will build if the compressor is left running and no devices are left open. By the way these compressors operate, we want to make sure that doesn't happen. So we need to relieve the pressure as the compressor is running. This can cause pressure to build to a dangerous level that may damage the irrigation system and create a hazardous condition. When we go to select an air compressor, we can use this chart. This is also in the brochure. Determine the maximum number of sprinkler heads that can be operated at one time with the compressor by the sprinkler nozzle size and the CFM rating of the compressor. 30 psi is the minimum pressure required to operate a Toro sprinkler. We don't want to exceed 50 psi. You'll see on the chart here below there's a column for 35 psi and a column for 50 psi. Now, using the chart as an example, to operate 11 heads with what's on the chart here as a nozzle 4 at 50 psi, if we follow down 50 psi to where we get to 11 heads and follow over from nozzle 4, we'll see that's a 500 CFM compressor. The X4, to explain what that means. In each one of the Toro series sprinkler heads, there's a 34 nozzle, a 54 nozzle, such and so forth, an 84, a 64. You'll see several different ones. They all end in a 4. That 4 is an indicator of how much cubic feet per minute of volume of air can come out of that nozzle. So this will help us determine what size CFM compressor we should use if it's our choice, or what size compressor we'll need if we do the math backwards to say, well, we've got 1,000 heads we want to get done in a day, so we're going to need this size of compressor. One of the other things that has come along is HDPE systems. So whether you have a PVC system or an HDPE system, you're not just hooking your compressor in through a quick coupler valve. You're trying to make some sort of a hydrant where it's at least 2 inch in size, so you're getting a good volume of air in. Then you're going to take a regulator setup from that back to your compressor. Now, one other thing that is of note, these compressors can get very hot. That air that they produce, pressurized air, is very hot. So to avoid damage to the plastic piping systems, the HDPE piping systems, you might want to use a length or more than one length of 2-inch galvanized pipe along the ground to dissipate the heat prior to having entering into the irrigation system to prevent damage. Some notes. Golf course systems require a higher volume air compressor, so excessive heat is generated. That's what we were just discussing on this last slide, at the point of air connections to the system. So again, put some galvanized pipe in as a couple lengths, hook it up with some temporary fittings, and let that temperature of the air get down to the point where you can still put your hand on that connection as it goes into your system. The Toro company recommends the use of pressure gauges installed into the areas where the sprinklers are being electrically activated. Monitoring this pressure can allow you to maintain the appropriate number of sprinklers at any one time. If you activate too many heads, the pressure will drop and the heads might not operate. Or too few heads and you'll see that pressure climb, and we need to get some more heads turned on or orifices opened up so that we don't create any damage or injury. And each crew should have a gauge that moves with them from location to location so that they can monitor the pressure as they're doing the winterization. Electric valve and head sprinkler heads, again, can work at a minimum of 30 psi and shouldn't be operated any more than 50 psi. What we'll do next is just go through in diagrammatic view this same information. 2 days prior to blowing out with compressed air, we want to open the high points in the system, the low point drains, and allow the system to drain naturally. We want to identify locations where water collections are likely to occur, pockets, low points. We want to make sure when we attach that compressor, we've got it set to between 35 and 50 psi. Attach the compressor at the highest point possible is where we like to work from. If you can't, attach it where you can. Introduce the air into the system to force the water out the low point drains. Close the high point drains as we proceed from the highest to the lowest until no water is present from the low point drains. Then close the drains starting from the highest to the lowest points. Again, this whole time making sure that our pressures do not exceed what we're trying to contain them at. Step 3, we want to again regulate the compressor 35 to 50 psi. And now we want to prepare to briefly activate as many sprinklers as possible based on the size of our compressor while maintaining enough pressure to activate these sprinklers. So we're going to turn on each sprinkler head once, forcing water out through the nozzles until a light mist is achieved. As the heads are turned off, new heads will be turned on to maintain continuous flow and pressure. We want to continue moving from the highest elevation to the lowest, pushing the water down the hill when possible. You can see it in the diagram as we're moving that water down the hill as much as possible. In the water collection locations that we've identified, or the 2 days that we were letting it drain, we either remove the riser assembly or we can insert the little riser hold-up tool and activate the sprinkler again to remove any residual water. And this time now, with the tool, we can activate it multiple times. We don't want to leave it too long in just sitting there running so that it doesn't melt anything in the drive assembly, but we can turn it on and off a couple times as required. Again, moving from the top to the bottom in elevation. And after we're completely done that, we close off the winterization tap. We store everything in preparation for winter. So just one more time through the quick reference guide. 2 days prior to blowing out compressed air, we want to open the high points, the low point drains, allow the system to drain, identify locations where water collections are likely to occur. We want to attach the compressor at the highest point possible, introduce air to the system to force the water out the low point drains. We want to close the highest point vents from the highest to the lowest points until no water is present for the low point drains. Then we want to close the drains again from the highest to the lowest points. Step 3, regulate the compressor to make sure it's between 35 and 50 psi at all times, and activate as many sprinkler heads as possible while maintaining enough pressure to activate those heads. The minimum pressure is going to be 30 psi. We want to turn on each sprinkler head once, forcing the water out through the nozzles until we get a light mist. As the heads are turned off, new heads need to be turned on to maintain a continuous flow and pressure for the sake of our air compressor. Then, step 5, in locations that we've identified as low pockets, we either remove the drive assembly or insert the riser hold-up tool, which is a 995-102, and activate the sprinklers again to remove any residual water. And this time we can repeat that as many as we need to get those pockets of water out. Then lastly, close off our winterization tap, put everything away, store everything for winter. We've spent a lot of time now about the irrigation and the fluid side of things. From the controller's perspective, we want to leave all the field controllers turned on all winter long. We want to leave all of our field interface or radios, any cabling, anything we have related to that system can all be left on and in place just like it would be all summer. Matter of fact, we would recommend that each month, even during the winter, the system be exercised. Run a dry run program. We know no water is going to be running, but let the system sit there and think that it's running one time a month and let it come back with the diagnostic reports or whatever you have to say that, yep, everything worked properly this month, so that there's no surprises for spring. And then at the end of the year, or sometime between winterization and end of the year, contact your service technician or NSN to get your database information backed up, get your system, your central cleaned up and ready for the new year. This is also a good time to have your grounds checked. If it's been a couple years, we want to make sure that those earth ground readings are below 35 ohms. 10 ohms is where we would like it to be. But again, if this is the real world we live in. So if your readings are above 35, you really should put some budget money in there and look at dealing with them. This would be the time that you would then have to improve them before the irrigation system begins next year. Thank you. We hope this information's been helpful. If there's anything we can do, please don't hesitate to give us a call.